Let me take you down on a relatable story. You're building a payment system. The first version only had cards, so you wrote a simple function which just takes cards. But a month down, your project manager came in and they asked for PayPal, so you added PayPal. Another month later, crypto was the hype, so eventually you ended up adding crypto. But what if you have to add bank transfers and Apple Pay next? And at some point, you've got this one function that everyone on this team is scared to touch because it's doing 3 jobs, and changing one thing might quietly break another. You've written code like this. Maybe it was payments, maybe it was export formats, maybe it was notification channels. The name changes. The shape of the problem, it doesn't. And that shape has a name. So here's what the function looks like. Your process payment function has 3 branching if-else statements. And all of them do completely separate things. They have nothing to do with each other except that they all somehow involve money. But the problem here is that every new payment method means that opening this function and modifying this code is going to be a hassle because this is code which is already working and you're touching code which is already working for adding new stuff, and that's the real problem. It's not even a mess, it's a risk. Before jumping to the solution, I want you to look at these 3 branches and notice something. Card processing has some steps. PayPal has some steps. Crypto has some steps. Completely different steps internally. But from the outside, from the perspective of the checkout flow, they all need to do 3 things. They all need to be initialized. They all need to create a charge, so that's actually taking the money somehow. And they all need to make sure that the payment landed. The thing is, how they do either of these 3 steps varies wildly. Card payments are synchronous, you charge it and it's done, you would instantly see a payment result. Now bank transfers, that's an example we haven't touched at yet, but this may take days sometimes. Crypto needs to wait for block confirmations, but the checkout flow doesn't care about any of that bullshit. It just needs to drive the same lifecycle regardless of what's underneath. Despite having completely different implementations, they all share the same lifecycle. And that's your tell. Whenever you notice that, that's your signal that an interface wants to exist. And here comes the strategy pattern. A strategy pattern's most important thing is abstracting all of this into an interface. An interface is basically just a contract. It says that anything which must call itself a payment strategy must have an init checkout method, a charge method, and a poll status. Init checkout sets up whatever the provider needs before money moves, a session, a token, a redirect, or whatever. Charge actually initializes the payment charge, and poll status checks whether it went through. Because for some providers the answer isn't immediate, for example bank transfers. That's it. Nothing about how any of those work internally, just that they have to exist. Now checkout can be written against this contract instead of against any specific provider. It doesn't say I work with PayPal, it says I work with anything that has this lifecycle. And that contract is open to things that don't even exist yet. Bank transfers, Apple Pay, Google Pay, and whatever your PM is fancying about next. All of that is possible. As long as it fulfills the contract, checkout doesn't change, not even one line. So how do you get there from this messy function? Look at each branch and ask, what life cycle does the caller actually need to drive? Init checkout, charge, poll status. That's your contract. The second step is pull each branch into its own class. Each one implements all 3 methods with whatever internal logic that specific provider needs. Checkout now holds a reference to whichever strategy was passed in, and that drives the full life cycle. No conditions, no branching. Checkout literally doesn't know if it's waiting for 2 seconds or 2 days, it just drives the contract and lets the strategy handle the complexity. Interface defining the lifecycle, concrete classes implementing that lifecycle in their own way, context driving the lifecycle without caring who's underneath. That's the whole pattern. And the next time you see a growing chain of if-else statements where every branch is doing the same job differently, you know what's missing. The next time you have to implement something like this, remember,